Now, in order to CNC my part, I need to set up my CAM. CAM software can typically be expensive, so kudos to Fusion for having this no-cost limited license. Under the stock setup, I'm going to change my offsets to 0 and check that my origin is at the center and top of my model. I'm going to start by configuring the features I want to machine using my 100 micron tool. In this case, it's going to be the 2D pocket for the cross-junction consisting of the 200 micron width channels and the 100 micron nozzle. I'm going to select my 100 micron tool, which I've previously configured in my tool library. And if needed, there's a quick walkthrough on how to add a tool to my library at the end of the video. Fusion is nice as it always has these reminders on each of these configuration settings in case I need more details. Now to select the machine geometry, last time when machining the serpentines, I was able to click on the interface of the channel I wanted to machine. Let's see what happens this time when I do the same thing. I'm going to go ahead and configure the remaining settings. Turn off stock to leave. Under multiple depths, I want to control the step to 50 micron steps, meaning instead of cutting all 100 micron depth at once, I'll cut in two 50 micron steps in order to get my final cut depth of 100 microns. And then for the ramp, let's select plunge. Let's see what happens when I click OK this time. It gives me an error this time because the CAM software doesn't know what to do with the holes connected to the channels. So the way to address this is to go back to the design and turn off the channels attached to the cross junction. When I go back to the manufacturing tab, I can hit regenerate and then it should recognize the pocket. Now, here's another issue I've run into. The software thinks that my 100 micron channel width is too small for my 100 micron end mill. To resolve this, I'm going to go back to my design, and in the sketch for my nozzle, I'm going to add 1 micron to the width of my channel. Now going back to the configuration, I can regenerate or reconfigure the pocket. Now this time, the software is able to generate the toolpath for the thin nozzle. I'm going to simulate real quick to verify that it's set up properly before I lock the configuration. To lock it, I'll just go ahead and right-click and hit Protect. Now let's move on to the remaining features. Let's go back to the design and restore all my other features, and then head back over to the manufacturing workspace. When I click on the 2D pocket I just configured, I can see the tool path is conserved. I don't want to use my 100 micron end mill to machine all the other channels because that would take up too much time. It would quickly wear out my small tool. So for the 500 micron channels, I'll be using a 300 micron tool. If machining multiple chips, I'd probably want to use a 400 or 500 micron tool instead, but since I already previously set my speeds and feeds, I'll just go ahead and use my 300. Go ahead and configure everything, and just to show what happens, I'll select the pocket like I did in the past. Select stock to leave uncheck, and then for multiple depths, I want to do a quick one-step cut, so the 100 micron depth is cut with one pass. For the lead in, I'll go ahead and do plunge, and then hit OK. It's going to give me the same error because it doesn't like the holes that are on the same surface as the channel. So I can go back and do the same thing. Go back to design, suppress the holes. And notice how this also removes the fillets I previously added. Now let's see what happens when I regenerate the toolpath again. I'll show a second method in the end. Notice how when I do the simulation, the software automatically generates the radius that it previously modeled into the CAD. And let's see the dual simulation to see what the cross junction and channel looks like. Now to make my holes, let's go ahead and protect this 2D pocket before I go back and suppress the hole features. For the holes, I can use the drilling feature. Change the offset to 3 to reduce the waiting time, and let's use the deep drilling to clear the hole as it's being cut. And let's do the quick simulation to check that everything's cutting properly before I move on to the final outline. The final configuration is fairly straightforward. It's primarily used to cut the final shape of my microfluidic chip from my stock material. And because I previously measured my material thickness to be 930 microns, I'm going to include a 0.1mm bottom offset so it doesn't cut all the way through. I can always manually remove the chip from the remaining acrylic after it's done cutting. For demonstration purposes, there's an alternative way to configuring my 500 micron channels if I don't want to turn off and on my features all the time. I'll go ahead and set up the same channel as I had previously, just by clicking on the face of the pocket. Okay, let's go back and reconfigure the geometry. Under geometry selection, I'll use the chain instead. For the first pass, I'll go ahead and select the edge located at the surface of our channel profile. Let's hit OK and see what happens. It doesn't look quite right, so let's go back and reconfigure. But this time, let's try selecting the top chain. Looks like I only recognized one side of the chain, so I need to select the opposite chain to fully enclose and get my machining profile. Now it looks right. Let's quickly inspect the toolpath. It looks like it's not actually cutting, so I'll need to manually compensate for the cut depth and the height setting. For the bottom height, I'll go ahead and enter minus 0.1 to get my 100 micron cut depth. And finally, let's go ahead and post-process all my configurations to get my files for machining. It's always good to just double check that the pockets are configured appropriately for the heights. Typically, I'm looking at the Z. I check that it's 0.05 and then 0.1 as a two-step process to get my 100 micron channels right 0.1 millimeter end mill.